Good morning and welcome to Recipe for Success. My name is Nancy Giacalone, and thank you so much for joining us today. I have a wonderful guest today that is going to talk to us about all sorts of interesting things. Kristine Ashcraft with Invite.
Invite, correct.
I should have asked before we started, but for those of you that tried to join me last week and maybe found that there was no feed going on, I have to admit, apparently I had some sort of short circuit in my brain because I told myself that the podcast didn't start till 10 a.m. Now, mind you, it's never started at that time. It's always started at 9, but somehow that's what I was thinking. So we got started a little bit late last week. So thank you if you are joining us today. I'm very excited about today's topic because Kristine is an expert in precision medicine, which is a very interesting topic. And it's really based on pharmacogenomics.
PGX for short.
PGX, I like it. That's what we're going to say today. But you can put the words together and you can understand it is pharmacy based on the specifics of your genetic makeup. So I think that it is really interesting. And again, the reason I'm excited to have Kristine here is, she is a force to be reckoned with. She has been interviewed on national news outlets. She has testified. She is the former CEO of UScript, which was acquired by Invite, which is why she's with them now. And she's published many articles. So I'd love to have Kristine introduce herself to you and tell you a little bit about your career path and what drove your interest in this specific area of medicine.
Sure. So I, unfortunately, like many people, lost a loved one to cancer when I was in high school. My grandmother passed away, and I wanted to study genetics. My dream when I was a teenager, I was going to go find a cure for cancer. And so I studied molecular biology in college, and I found that although I found the subject matter fascinating, bench work was really not my speed. And so after college, I actually started in sales. I ran an insurance call center for a while and then saw an opening at a laboratory, Genelex in Seattle back in 2000 to run their sales and marketing division. And they were one of the first genetic testing labs out there. They invented some of the first probes used for DNA identification for forensic purposes. So started way back in 1987. I joined in 2000, and soon after joining, read an article in Fortune magazine about a little boy named Michael who died of an overdose. He had an easily testable pharmacogenetic PGX variation that, in concert with his other medications, led to deadly levels of Prozac in his system. And the story talked about the dawning of the age of precision medicine, when we would use genetic information to be certain we were getting patients the most safe and effective drugs and doses for them. A lot of other applications in precision medicine, but this has really been my focus. So we became one of the first CLIA accredited labs in the country to offer that testing. And over the years, I have had a pretty unique opportunity to speak with literally thousands of patients, payers, providers about widespread barriers to adoption of this technology that can save people's lives, reduce healthcare spend, keep people out of the emergency room or hospital. And the questions were really the same. Well, how do I know who to test? Who's going to benefit most? The answer is everybody, but there are ways to target it more specifically. How do I know how to act on that in the context of other things that impact drug response? Because it's not just your genes. There are other things going on. You take other drugs, grapefruit juice, smoking can all impact how you respond to drugs. And where are the studies validating this actually improves care? So in, I'd say 2005, I think we were early 2000s, we were lucky enough to stumble across a software program originally created by a couple of really frustrated Harvard psychiatrists that ran into drug-drug interactions in their practice that the tools they had available for them just didn't warn them about. So they actually curated the literature to understand the biological basis for how these things happened. I think that the layman's way to think about this, like when you take drugs, you usually take them in an active form, and then they go into your liver and drive on these different cytochrome enzymes. Think of them like highways. So in Seattle, I-5, 99. Some only want to drive on I-5, some half on I-5, half on 99. And our genetics dictates how many lanes of these highways we have in our liver. So they had actually looked at what drugs drive on what highway and what drugs send signals to shut lanes down or open lanes of these different highways. So we were able to upgrade that software to take genetics into account, started offering it with the testing. And then the docs were like, hey, love this. This is actually the best tool I've ever seen for medication management, but you need to put it in my workflow, in my electronic health record, or I'm just not going to use it very often. So back in 2013, we won a HIMSS Health 2.0 Open App Challenge for integrating that into the EHR for the first time. Now have it in Epic and Cerner. And then I spun that software out of the lab in, I think, 2016. And now we're both part of Invitae. And Invitae's mission is really to make genetic information accessible and affordable to everybody that can benefit from it. So really working to make this standard of care now.
I love it. So I think that the topic of genomics, I'm apparently not going to be able to say that today. PGX, I can say it just fine in normal days, but on air, apparently, it's just not going to come out. Genetic testing, I mean, I think it can sound foreign and a little bit scary to people. Can you break it down for the layperson and explain what that test actually is and how they can potentially benefit from it?
Yeah. So back to this highway analogy. So most of the time we take drugs again in an active form, and then they hit these different highways, sometimes only one, some 2 or 3 in the liver to get converted to what we can then flush out and get rid of. Some drugs we take in an inactive form, and they have to drive on these highways to even work. So genetically, we pretend everybody has 2 lanes of these different highways in the liver that process a lot of medications. Genetically, some people are intermediate metabolizers, 1 lane, poor metabolizers, no lane, or ultra rapid, 3 or more lanes of these genetic highways that process, or liver highways that process medications. And so you can get a genetic test and understand what medications are potentially problematic for you, just like traffic, right? If I-5 is completely shut down and we put a bunch of traffic on it, what happens? It backs up. And that's when we start having adverse effects. That's when people can end up in the hospital or emergency room or even die on the most severe end. On the other end, if you have lots of extra lanes, no traffic, what happens? It goes flying through, nothing's stopping it. And so you don't get treatment benefit from the medication. I remember, back in the day, we used to plan road trips and we would fold those paper maps out in our car, right? And now everybody has the real-time traffic app on our phone. And essentially what the pharmacogenetic testing does is enable us to understand our personalized highway map. So then when we lay the traffic on top of it, we can reroute just as we can with our mobile apps. Okay, I-5 is completely shut down, take 99. If you need something to lower your blood pressure, there's another drug that goes on that different highway in your system. And so it's just really moving from one size fits all to understanding when a patient would need a lower dose, a higher dose, or a different medication altogether.
So I know that PGX testing can be more valuable for certain conditions or certain drug classes than others. What are the areas where it is the most beneficial?
Yeah, I think the thing to keep in mind, the same genes. So ideally you do a panel that covers all of these different highways that drugs encounter in your system. And you use that information over and over again to optimize drug and dose selection. And this impacts virtually every area of care. But I'd say the main ones that we see applications are for mental health. Virtually every antidepressant drives on these very variable highways that your genes dictate how many lanes you have. So if you have that information, it shortens the trial and error. A lot of times somebody is depressed or anxious or like, here, try this, come back 6-8 weeks, tell me how you're feeling. You cannot guarantee you're going to get the perfect drug and dose from the beginning with the pharmacogenetics, but you shorten that trial and error time. And so you get them on the better medication faster. Another area that's super important, we hear a lot about the opioid epidemic. So pain medications, codeine. Codeine is a very commonly prescribed pain medication. It is taken in an inactive form. It actually drives on one of these liver highways, 2D6, to provide pain relief. It gets converted to morphine in our liver. And so if
Interesting.
you're
I
a
didn't know
poor,
that.
yeah, if you're a poor metabolizer, you get no pain relief from codeine. If you're an ultra rapid metabolizer, you convert so much, you're at risk of toxicity. And some people have admitted getting a high sensation because they get exposed to a lot of that morphine in a very short window. So a number of years ago, they actually put a black box warning on codeine. They said, stop giving it to kids because some children with ultra rapid metabolizers converted so much to morphine, they actually died after a simple adenoidectomy or tonsillectomy. They also recommend not giving it to nursing mothers because they convert so much that then passes on through the breast milk.
Sure.
And then the other, I think, biggest area of application is cardiology. So Plavix or clopidogrel, very commonly prescribed to keep a patient from having a heart attack or a stroke. And it doesn't work for patients with certain pharmacogenetic variants. And so very easy, you just give them a different medication if you know that. But if you don't know that, the repercussions can be really severe, but also impacts cancer medications. So for women, tamoxifen is very commonly given to prevent breast cancer recurrence. Again, doesn't work for patients with certain pharmacogenetic variations. So you know that, you give them a different medication.
Yeah. There's a comment here I think is really important. It's from Dale Sagan. He says, I had this test done and was fascinated with the results. Curious to hear how someone should carry this around for their life when they may need one of these drugs in 20 years or more. I think that's a great question.
It is a great question, and it's part of what I work on. So the UScript clinical decision support tool that we are integrating into more and more electronic health records. We work with a number of pharmacy benefit managers as well. These enable when a prescription comes through to go, hey, we've got the pharmacogenetic test results on file, kind of like we save allergies. Like when you go to the doctor, are you allergic to anything?
Yes.
Right? We would have discreetly stored the results. And so it would say, here's all the meds the patient's on. Here's their genetic test results. Here's the new medication we're thinking of giving them. And it essentially pings against the equivalent of that real-time traffic app on your phone, only for medications, and says, ooh, everything's fine, or metabolic traffic jam. That patient is not going to respond to that medication. Click here to find a safer alternative, taking all of their drugs and genes into account. So again, very much like the real-time traffic app, here's a med that does the same thing that you can use instead for this particular patient. So we're integrating that into the workflow for more and more providers. We also hope to have a more patient-facing application soon, where the patient can actually have their own prescription checked whenever they get a new one against that.
I love that. Another question we have is, should everyone get this test, and is it really expensive?
I think everyone should get this test. I gratefully do not have to take any medications on a daily basis, but I tore my ACL clean in half a number of years ago when I was skiing. And I sure was glad to have that information on hand so I could make sure they were giving me the right pain medications when I needed them. So yes, and the answer is it's not very expensive. Good news is for Medicare patients, this is often covered. So for a growing list of medications that either the FDA, the safety body for drugs, or CPIC, which is the guidelines body for drug gene interactions, they say they're high evidence and actionable. Medicare will cover testing if the doctor is going to change the prescribing based on the results. So you're not responding, you've had issues, adverse effects, or they're about to prescribe a medication that's impacted. They will cover testing. A lot of commercials aren't as good, but at Invitae, we have a very low cash pay rate. If you type in Invitae pharmacogenomics, you can go through and a telehealth provider will assist you with that. And you could go through the HSA or FSA, but it's less than a few $100s. It's certainly worth it for the peace of mind.
That's awesome. So when you and I first chatted, I realized that I had actually had a test done through Invitae, 2018, 2019. I don't remember exactly when it was, because I was first introduced to the idea of PGX as it relates to cancer. I was at an industry event, and I'm always just very fascinated by the role that genetics plays in our health and the way we treat our health. So I always like to be a guinea pig for any product that's out there. And I'm like, okay, we'll give it a try. It wasn't the full test like what you're talking about, which I'll probably have done before long, just because I'd like to be armed with that information. But mine was to test for specific cancer markers, et cetera, which fortunately I did not have any. But I took the whole test to my doctor and I gave it to him because it had some other, valuable information in there. And I said, I'd love to have this as part of my medical records. And he says, we don't have any use for that. He wouldn't even take the information. So he's no longer my doctor. I'll put that out
doctors.
there.
That's my first.
I will put that out there. He's no longer my doctor. But how much resistance are you finding in the medical community from doctors saying, that's just too much work for me. I don't want to have to worry about that.
Yeah, I think it depends on the doctor. The adoption curve, you've got your innovators, early adopters, early majority, late majority, laggards. I still think we're climbing that hill on the early majority for pharmacogenomics and precision medicine in general. There was just research that came out at ASCO recently showing that the rates of hereditary cancer genetic testing. So if someone actually is diagnosed with cancer, they're still not ordering hereditary cancer genetic testing when they're supposed to, like more than half the time. I don't remember the exact percentage. But this really matters. People know when you get cancer, a lot of times they'll take the tumor and figure out if your cancer tumor is going to respond to a certain therapy. But your hereditary genetics, the stuff you get from your mom and dad, is also important. I think the one we're most familiar with is probably BRCA. Angelina Jolie really brought that front and center. But you respond to different therapies. And it's important to know that because it also impacts family members. It's not a death sentence if you're BRCA positive. You're way, way more likely to get breast and ovarian cancer. But if you know that, especially you learn when you're 18, right? You could maybe decide to have children earlier than you might have because you're going to elect to have surgery later before your chances start increasing. So it gives you power. We actually have done a lot of cancer genetic testing for patients diagnosed with cancer. But we do also a proactive genetic screening. So we do the pharmacogenetics. That's one thing. The proactive genetic screening I find fascinating. This is 167 genes that were selected to look at hereditary risks that are actionable. So it's not, hey, you have this and there's nothing you can do. Sorry, you have increased risk for Alzheimer's. We unfortunately don't have a cure for that yet, right? Instead, we look at things that you can proactively manage. Both cancer, cardiomyopathy, and other cardiac risks. And also, interestingly, factor 2, factor 5, hemochromatosis, which means you load iron. So we do this as a employee benefit at Invitae for all of our employees and their family members. And my husband was tested. He's Danish by ancestry. And we found out he had familial hemochromatosis, which means you load iron. And so I was like, go to your doctor, get your iron and ferritin levels checked. His ferritin was almost 1,000. When it exceeds 1,000, you can start causing permanent organ damage. So at first he had to do therapeutic phlebotomy, which is like give blood and then they toss it. But now that his iron and ferritin are normal, he just donates blood every 2 months to keep healthy. And we were this far away from him having some severe medical consequences. And I work in genetics, and I wouldn't have known that if I weren't part of Invitae.
Yeah, that's crazy. A couple other comments. Dale mentioned that's what his doctor said too, which is why he asked. And then I will connect the two of you, but Amber said she just graduated from a genetic counseling. So yes, that's a side note. The other thing I wanted to touch on a little bit more in depth is, we've more or less come out of the opioid crisis, but pain medication is still a huge issue for a lot of people. And I do know that genetic testing can really identify the most appropriate medications or the ones that a person will not respond well to and is more likely to become addicted to. Can you speak to that a little bit? Because I think that, anybody could have something happen and be prescribed a pain medication, which could change their life.
Right. So I talked about codeine. Tramadol is another one. You take it in inactive form and it's converted to what actually provides pain relief. So for poor metabolizers, no pain relief. Ultra rapid metabolizers, exposed to too much too fast. I was reading a study that showed in opioid dependency treatment, the rate of poor and ultra rapid metabolizers for that particular liver enzyme 2D6 is about 20%. It's 8% in the US population at large. So what happens, I imagine, I don't know, this is me thinking of what happens. So I'm a poor metabolizer. This pain drug isn't working for me at all. Oh, you're a drug seeker.
Right.
Right? So what am I going to do if I'm in pain? I'm going to go find a way to manage my pain outside of that,
Right.
which is going to expose me to addiction, right? For medications. And then on the other side, the ultra rapid metabolizers, there are case studies of people admitting that they like the high sensation. So unintentionally being exposed to way too much, way too fast, that is avoidable. I mean, you literally have to do a affordable test one time, store it discreetly, and continue using it. Back to the question of how do you keep this alive? We do have a high evidence drug gene interaction table we provide to every patient that highlights drugs in red that they should avoid from a genetic standpoint. Ones, with orange triangles, that means that they need a different dose. And then yellows just monitor more closely. But that is something I encourage anybody that's tested to take to every doctor that they have. And if something is in red for major or contraindicated, add it to the allergy list. It's not an allergy,
idea.
but put it in the allergy list.
That's a really good
one
idea.
way to keep it alive. Yeah.
Yeah, that's a great idea. I just think that it's so easily preventable. If we just took one simple step, and like you say, it's a one-time thing, and then you have that information on hand, and it could really make a difference in a lot of people's lives if they're, avoid potential addictions. Where do you see the future of genomics in targeted medical treatments, not only pharmaceutical, but just in general?
In general, I think we're getting closer to a point. Like when I first started in pharmacogenetics, we did a single drug gene test. Like we'll look at this one highway, run a test. Now we have a comprehensive 38 gene panel that looks at all sorts of high evidence drug gene interactions across all of these different areas. Our proactive genetic screen over here is 167 genes. We look at diagnostics for rare disease. I think we're not very far away from a comprehensive genomic look at a patient that is on their file for life. It's stored and queried as needed. So, okay, let's look at hereditary risks you may have. You don't need to tell a 3-year-old they have that. Maybe you tell them when they're 18. If it's something that needs to be treated when you're young, sure, that information would come out to their parents. But feeding the information at the right time in care, I think there'll be a lot of layers on top of that. We know not all genes manifest, right? So we have blue eyes if that's what was given to us in our genes, but a lot of genes have to be turned on or off by different exposures. So we have to layer on the information to figure out what exposures turn on certain things that aren't going to manifest in everyone. You may have a genetic predisposition, but that doesn't mean you're absolutely going to get something. So how do you reduce that risk when you're aware that it's happening? So I think there'll be, layers, proteomics, your microbiome, et cetera. But all of that will be stored and accessible.
So how do you think that we get that type of information out to the general public? Because right now, most healthcare providers are reactive rather than proactive. And that's not a disparagement to them or anything else. They're overworked, they're just don't have enough time. They're not spending time with people talking about, here's the things that you're prone to, and here's the things that you can do to, stay as healthy as possible for as long as possible. I really think that although it's super important to have it in the medical community, this information really needs to get out to the general public as well.
Yeah, I definitely agree with that. There are a lot of different people working on this in different ways. So Swalwell and Emmer last year introduced a congressional act called the Right Drug Dose Now Act. And this would help address some of the barriers to adoption of pharmacogenomics, one of them being education of medical providers. So allocating funding to help healthcare providers understand just how important this is, and would also incentivize integration into the electronic health record. So if you go to the doctor or pharmacy now, they have to flag for drug-drug interactions. Drug-gene interactions are very similar. It's a very similar mechanism of action. It's just a different cause of shutting down those highways.
Right.
And so incentivizing that update. There's also something called the FDA Adverse Event Reporting System. This has been around for a long time. Now, adverse drug events are the fourth leading cause of death in this country. We lose a life every 2 minutes, 4 full 737s every day to adverse drug events in this country. And the way that it has been reported hasn't been updated since the late 90s. I think we were still using cassette tapes then. No, we had CDs, but still a long time ago. And this is a major cause of mortality and morbidity in our country. So it would also make it easier to report when there is a problem, streamlining that process and improving how we learn what's going on. So they're going to be not Swalwell and Emmer, but some additional congressional people will be reintroducing that this year. And that will help improve education and adoption. I think, though, that you're right on the patient front. When patients hear about this, they tend to advocate for their own care. I remember early on tamoxifen, 2D6 testing. The breast cancer community went into their doctors demanding that the test be ordered. Mm-hmm. It was not, for the most part, the other way around. And so I don't have the answer to how to get that out there better. I would love to. I know me and others in the PGX community say yes to things like this all the time, so we can help educate people. But
it seems like
/Right Act, I will say, if you want to learn more about the congressional efforts, they will help.
I will look at that. I think, in all honesty, if I think about it, it should be covered as a preventive service.
So the U.S. Preventative Task Force, yes, ideally,
that's where it should be. That's where it should be covered, because if it's covered there, then it would be more likely that more people would actually take action on it. Because if you think about a large majority of the population, they don't go to the doctor. They don't go to the doctor because it's scary. They don't know what the doctor's going to say, et cetera, et cetera. And if there was a benchmark at a certain point in life, let's say age 15 or whatever 12, 5, I don't care really where it is, but if there was a benchmark and that was just part of the, your vaccines and everything else that you were doing as you got tested, and then that becomes part of your medical record, it seems that would be enormously valuable to not only the patient, but to the medical community as well.
Right. I think it makes a lot of sense in newborns. They detect a lot of rare diseases. And if it's done on all newborns, you can detect things when it's very easy to treat them. What happens a lot if there is a genetic disease is that there's a very long diagnostic odyssey. And sometimes by the time the diagnosis comes, it's too late to stop the pain, suffering, like you can't. Whereas sometimes it's as easy as giving them some kind of dietary change early on to avoid this disease progression. So I think ideally we will get to a place where it's done when you're a newborn, it's stored, and it's fed out at the appropriate time.
Yeah, that would be amazing. And just because I think maybe a lot of people don't know, can you explain what's involved in a genetic test? What does the individual have to do? Because it's a lot less scary than people think it is.
Yeah, it depends on the test, but let's say you wanted a pharmacogenetic test that helps determine if you need a different drug dose or medication altogether for a long list of very commonly prescribed medications. If you went to Invitae, you could get a telehealth provider to order that test for you, and a cheek swab collection kit is mailed to your home. It looks like a long Q-tip. You just rub it on the inside of each cheek, pop it in an envelope, either take it to your mailbox to get picked up by the post office, or you can FedEx it if you prefer to go to a FedEx. Gets to the lab, they notify you your samples arrived. And then a few weeks later, you would get results in the mail. One would say, hey, here's your lab results. You don't need to pay a lot of attention to that. That's what the accrediting bodies make us send. It's like 2D6 poor metabolizer, star 3. Yeah. But you will also get that high evidence drug gene interaction table I talked about. That's going to have medications you should avoid, medications you may need a different dose for. And then what's really great is you have the ability to share this with all of your healthcare providers. So you can share it with your cardiologist, your primary care doctor, your psychiatrist, and they get access to additional tools. One is this UScript clinical decision support tool, where they can audition new medications against all your drugs and genes, find one-click alternatives by class or indication. They're the ones that actually get this, real-time traffic app for your meds, and you can share that access. So that's very easy. For our genetic tests that are more, hey, you have BRCA, you can do that if you're healthy and it doesn't run in your family. If it does, like, it's usually covered by insurance, right?
Right.
So it's routed a different way, and we'll look at variants of uncertain significance, et cetera. But say you're doing a proactive genetic screening, like the one I mentioned. Do I have cancer risk? Do I have cardiomyopathy risk? Do I have hemochromatosis? That will actually recommend that you schedule an appointment with a genetic counselor at the end if something is found, and route you to them so you can get your questions answered. They give you recommendations for a care plan. Like, go make a appointment with this kind of provider, et cetera. So doesn't need to be scary. I think it's really about understanding that all of this is power, right? You're empowering yourself to take better care of your health.
Yeah, I love it. All right. Well, we have made it to the fun part of the show, and you get my 5 burning questions. So are you ready?
Burning.
So in line with the theme of the show, what is your absolute favorite food in the world, and can you cook it?
My absolute favorite food in the world is sushi and sashimi. I mean, I could certainly slice some sashimi grade ahi myself, but I prefer to leave it to professionals. There's a lot of exceptionally good sushi in Seattle. So
There is.
I can cook, but I don't make that.
Okay, that's fair enough. So what is the one character trait you admire most in other people, and why?
I thought a lot about this. I was actually chatting with my husband and stepdaughter last night about it. And I think it's being an autodidact, like really being able to teach yourself and move beyond. I think people that teach themselves are ones that ask both themselves hard questions, other people, the status quo. And that's really how we make progress. It's not just, hey, learn this, keep doing it the same way that people have already done it. But really questioning, how do we move from reactive to preventive medicine? What do we need to do differently?
Right. I like that. Okay, so if I flip the mirror on you, what's the one character trait you're most proud of about yourself, and why?
That wasn't on the list, but okay.
I know. That one's never on the list.
I think that I am willing to face my fears. I remember when I was getting my MBA, they had us do a career assessment, like what's holding you back. And I avoided public speaking like the plague. And they said, that's not really great if you want to be in leadership. You need to work on that. And so I signed up for Toastmasters and did the competent communicator. I've since spoken, in front of thousands of people multiple times. I got to meet Obama last year at a conference we were both speaking at. So
how exciting.
I think it's important to do that. It's okay to be afraid, but facing it head on.
Yep, I love it. How can an individual advocate for genetic testing if they have a condition that they feel would warrant it, such as cancer or heart disease? Since we brought that up, if they're at their doctor, how do they approach their doctor about that?
It's a great question. I would say there are a lot of resources. Invitae has some resources. You can reach out to customer care. Also, if you have a certain type of cancer, you can go to the resources. The nonprofits have created that, and they actually have guidance on genetic tests you should ask your provider about. I would say come prepared with something from a reputable site like the nonprofit or a accredited testing lab. Like, I should be getting this testing according to this guideline. According to the NCCN guidelines, you should be ordering this for me, not just Dr. Google, which tends to be dismissed, but a reputable source. I think Invitae, as well as other labs, like for pharmacogenomics on the website, we have a how to talk to your doctor letter you can download and take into them. I think you should order this testing for me. But I think those are the resources to bring in the reputable ones.
I like that. Okay, so this is always fun. What's your secret talent or something people would be surprised to learn about you?
My secret talent. So I am sitting here in my 1892 farmhouse, which that's really old for Seattle. This is a original homestead in our neighborhood. And when we bought it, somebody did everything terrible about the 70s to it. shag carpet over beautiful fir wood floors, everything. So we've had to remodel every square inch of this house. If you can see the wood behind me, I stained and polyurethaned every square inch of all of the wood you can see. I did all the tiling in the house. I installed the central vacuum system. Very handy. I was a military brat, and I learned to remodel homes when I was growing up and moving all the time.
I love it. That is a nice talent to have. I like it. Okay, so last question. Who's the one person, famous or otherwise, they can be living or dead, that you would most love to sit down in person with and have a conversation? And why?
I think this answer would change depending on the day, honestly, and where I am in my life. Right now, I'm just started reading Michelle Obama's book, The Light We Carry. And I'm just very, very impressed with her authenticity and ability to maintain hope in the face of a lot of adversity. I would love, love, love to have dinner with her and learn more about her journey one-on-one.
That's great. Excellent choice. Think you couldn't go wrong there. So again, if people want to learn more about Invitae, about PGX testing, about you, about Invitae, what's the best way for them to get more information, to get in touch with you?
Sure. So Invitae, invitae.com. I'm also on LinkedIn. Kristine Ashcraft, Kristine with a K. You can see my name there. Happy to connect on LinkedIn for anyone that's interested. And then my email is kristine.ashcraft@invitae.com.
Excellent. Well, and if anybody for some reason can't get in touch with Kristine, if you message me, I will be sure and put you in touch with her. So thank you so much. This was an absolutely informative session. I learned a lot, and I hope everyone else did here too. So thanks again for your time. I very much appreciate it. And I think I think it froze. Okay. So see everybody next week, and thank you for tuning in today.